covering section 9.3 today, and I would say, let me hide this for a second. I would say that the videos that you watched in preparation for today, the unit circle coordinate videos, if you remember correctly, back before the last test, I gave you a unit circle video, 2 of them, for the positions of the unit circle, the degrees and the radians. And I told you that that was the most important video you were gonna get all semester. Do you remember me telling you that? Okay, because this is unit circle videos, that's involved, okay? So I would say that the unit circle videos that you guys watch for the coordinates of each of those positions fall right in line with the most important videos you watch all semester long. Okay, so was there 2 videos, one for the 30-60 coordinates and one for the 45 coordinates? It was all together? Okay, so the 2 from the radians and degrees from section 9.1 and the 1 for the coordinates here, I would say that those 3 videos are the most important videos you're gonna have all semester long. Okay, so if you watch them and you kind of get what's going on, but not really, go watch them again. Watch them until you get it, okay? I have often told my students, my trig students, if you don't learn the unit circle well, drop my class. It's that big of a deal, okay? The unit circle is that important this semester. So, so just make sure that you really get a good grasp of those videos. All right, so, and one thing that I wanted to point out is the sticky note that I left you here, the Robert's rounding rules. I'll tell you a funny story. Well, I think it's funny anyway. You might not. I was teaching a Math 111 several semesters ago, and I had a girl in my class, and Robert's rounding rules are something that we use all semester long from this point out. And basically what Robert's rounding rules say is if the directions tell you how to round, then follow the directions. But if the directions don't tell you how to round, you're going to go 4 places. Okay? So in the semester, it was maybe 3/4 of the way through the semester, and I just asked my class in general, why are you rounding like that? And I had this girl, bless her heart, who said, you know, that dude, Robert, whoever he is, we have to follow his rules. Like, do you not know my name? We're like 3/4 of the way through the semester, and she just looks at me. I'm like, I'm Roberts. Those are my rules. I made them up. That's why they're called Robert's rounding rules. It's not some dude. That's me. So anyway, so yeah, I named it this because these are my rules. This is not something that the textbook follows. It's not something that the world in general follows because I'm not that important to the rest of the world. This is something that I follow in my own classroom. Okay, so if you're told how to round, obey. If you're not told how to round, 4 places it is. So that's a big deal, and I don't think I mentioned that on the video, do I? Do I mention that on the video? Do I? Oh, okay. I don't remember that video I took so long ago. And then the whole concept of exact versus approximate, this is also a big deal. All right, so the first embedded question that you could have gotten bonus points for, numbers 1 through 4. And so you're going to be using the triangle above. So this guy right here, you're going to be using this triangle to find these. So now I'm not just focused on the theta that's at the origin. Now I'm actually focused on a theta, an angle that's specific. In this case, for number 1, I'm focused on the 30-degree angle. It's not just a random theta at the origin, okay, like it was for section 9.1. So sine of 30, you want to focus on the 30. SOHCAHTOA says sine is what? Opposite over hypotenuse. So then according to this, what is opposite over hypotenuse going to be? Okay, so it's going to be, yeah, 1/2 over 1, which is just simply going to be 1/2. Oh, that's a little fat. Let me fix that. For number 2, don't focus on the 30, focus on the 60. Focus on the 60, okay? What's cosine according to SOHCAHTOA? Adjacent over hypotenuse, so what's that going to be? Well, that's kind of interesting, isn't it? Can you tell me a little bit about the number 30 and about the number 60? They're complements of each other. Interesting. Keep that in your head. Okay, we're going to come back to that concept. Now let's go to example number 3. Again, focusing on the 60-degree angle. Whose partner in crime is secant? Cosine. You just told me that cosine was adjacent over hypotenuse. So what is secant then? Hypotenuse over adjacent. Yeah, so when you look at hypotenuse over adjacent, what will example 3 be? Okay, yeah, so it's going to be, you could say it's the reciprocal of cosine. That's easy, right? Because the reciprocal of cosine is just 2 over 1. Or you could actually go through the work and say that it's 1 over a half hypotenuse over adjacent. Last but not least, let's look at the 30-degree angle. Focus on the 30-degree angle. What does SOHCAHTOA say about tangent? Opposite over adjacent. Okay, so let's show the work on this one. The opposite was 1/2, right? And the adjacent was what? √3 over 2. Of course, we'll never leave fractions like this. This is unsimplified. So how do we divide fractions? Multiply by the reciprocal. So it's going to be 1/2 times 2 over √3. My brain says the 2's cancel, leaving me with 1 over √3. You're going to leave it like that? No, you can't have a root in the bottom. So let's rationalize the denominator and you'll get √3 over 3. So for the record, you're going to end up doing either 1/2 divided by √3 over 2 or the reverse of that, √3 over 2 divided by 1/2. You'll do that so many times, you'll probably accidentally memorize what it's equal to. Okay, so like I'm to the point, because I've done this so many times, that I can look at this and I can automatically know in my head that's going to end up being √3 over 3 without working through it. Not because I intentionally memorized it, but it was an accident. I just did that so many times. Okay, you'll probably get to the same point as well. All right, and then we did the same thing with the 45, 45, 90 triangle. So then the next set of embedded question points is 5, 6, and 7. And so for this one, you need to focus on the 45-degree angle, and you say, which one? It doesn't matter, eeny, meeny, miny, mo. Okay, so then cosine of the 45 adjacent over hypotenuse is going to be √2 over 2. How about the cosecant? Now, you're thinking sine, and what's the sine value? Opposite over hypotenuse, which will be what? √2 over 2. And we know that sine and cosecant are reciprocals over each other. So this is going to be 2 over √2, the reciprocal. But you don't want to leave it like that. That's unsimplified. So rationalize the denominator. And that'll be 2 √2 over 2. Don't leave it like that either. It's still unsimplified. So cancel out the outer 2's. And then last but not least, actually the easy one, what's the tangent at 45? Yeah, 1. So you have √2 over 2 over √2 over 2. All right, complements and cofunctions. Have you seen this before? The sine and the cosine of 2 complementary angles are always going to equal each other. Have you seen that? Where did you see that? In example 1 and 2, right? You've got the sine and the cosine of 2 complements, and they're equal to each other. Now that we know that rule, that's not such a big shock, is it? Okay, so, but it not only works for sine and cosine, okay, it also works for secant, cosecant, and it also works for tangent, cotangent. All right, so there's the unit circle. Go back through that video. And this here is a statement that we made last class period. I just have a blank to fill in for this. Cosines tend to always be related to which values? We did this when we were talking about all students take calculus. X values. And sine always tends to be related to the Y values. If you think about the fact that they're both in alphabetical order, that might help. Cosine comes before sine in the alphabet, so does X before Y. All right. Honestly, these right here are not that difficult because we've already kind of been here, all right? We've already done something like this. Do you have your unit circle out? Remember, the unit circle is something that you're going to want to have out pretty much every day. So whether you have it maybe in a sleeve at the front of your notebook or something, but it should be readily available every single day. So this says that we're supposed to find the exact value without a calculator. So we shouldn't be using a calculator on these, okay? Now, when we did these back in 9-2, by the way, we did the same kinds of questions in 9-2. The first thing that we did, and I don't think I have a sticky note here, but I had a sticky note back in 9-2. The first thing that we did is we found out the position, okay? So forget about the fact that this is cotangent. Just tell me on the unit circle, where's 30 degrees? And by the way, the more you can do without looking, the better. So like for now, if you want to hide your unit circle or turn it upside down and only use it when you can't think of what it is, it'll be right there ready for you, but if you're also helping your brain to remember some things. So what position is 30 degrees in? Quadrant 1, can you be a little bit more specific? Talk to me in spokes. It's the first spoke into quadrant 1. All right, now the next thing that we did back in 9.2 is, you remember how you guys named a non-boring coordinate for me? Remember that? Okay, this time we're going to stick with boring. We're going to stick with the ones that we learned on the video. So what is the coordinate at the 30-degree position? Now, before you just go and answer me, remember that in the video, I talked about longs and shorts, okay? And so what I really would like for you to be visualizing in your mind is, hey, in order to get to that position, my X value has to be a long guy. My Y value has to be a short guy. Why? The reason I say that, do not waste mental energy memorizing those coordinates. Don't waste the mental energy. I don't have the coordinate memorized, but I can see with my eyeballs that the X piece is long and the Y piece is short. I don't need to memorize it as long as you can see it, okay? So what's the coordinate then? Long value? Root 3 over 2 is a long value, and what's my short value? 1/2, okay? So really, I'm doing the same process that I did in section 9-2, all right? I just have some different coordinates. All right, they're not on an axis anymore. Okay, cotangent. So let's think through what cotangent is. Whose partner is cotangent? Tangent, okay. And according to SOHCAHTOA, what is tangent? Opposite over adjacent. And if you remember correctly, that's the Y value over the X value. So what's cotangent? X over Y. So if this is going to be my X value over my Y value, what is this going to be? X value, root 3 over 2 over 1/2, okay? Remember, I told you were going to memorize this eventually, but we haven't done enough yet for you to memorize it. So this is going to be root 3 over 2 times the reciprocal 2 over 1, 2's cancel, leaving me with just a root 3. Okay, let's head on over to number 9. Same position. So I can use the same circle that I had for example 8. The cosine value is always related to which value? The x value. Hey guys, this is the unit circle. What is the radius of the unit circle always? 1. So really, as long as I'm working with the unit circle, I don't even need to think that it's my x value over my r value, because my radius is just 1. I really can't, when I say it's related to the x value on the unit circle, it is the x value, but only on the unit circle. Okay, every other circle in the world, you have to remember that there's an r there. Okay, so what's the cosine value then? Root 3 over 2. Oh man, I keep sticking with the same picture. How boring is that? Okay, who is cosecant's partner? Sine. Okay, what is the sine value on this picture? It's a half. It's the y value, right? Again, since it's on the unit circle, I don't need to pay attention to the radius because that's just over 1. Okay, what's the cosecant then? Yeah, 2, the reciprocal of sine. Okay, 45 degrees. Now I don't care about secant right now. First of all, let's get a good position. Where is 45 degrees? Say it, can you say it again? I just couldn't hear. In between 2 spokes, which quadrant? Yeah, good. So it's smack dab in the middle of quadrant 1. Hey, what's the coordinate? Try to give it to me without looking. What's the coordinate at my 45 position? Root 2 over 2 is the x value. What's the y value? Same thing, root 2 over 2. Okay. Whose partner is secant? Cosine. What's the cosine? Okay, so it's adjacent over hypotenuse, but remember that on the unit circle, you really don't have to pay attention to the hypotenuse. So it's just going to be it's just going to be the x value, the root 2 over 2. Oh, but wait, I didn't want cosine, I want secant. So the x value, the cosine value is root 2 over 2. But what's my secant value? Well, we got 2 over root 2, right? We just did that work a minute ago. Don't go and redo the work. We just did it. What did that end up equaling? Yeah, just the square root of 2. All right, let's jump down to number 12. Oh, man. I hit my scissors right at the same time that I had a notification come through. Okay, so we are on number 12. Where is pi over 3? First quadrant. Where in the first quadrant? Second spoke. Now, if your brain is automatically thinking in degrees, you need to train yourself not to do that. So be honest with me. Are you more comfortable with degrees or are you more comfortable with radians? Well, of course, because that's the one that you've heard about your whole life, right? I mean, you know, snowboarders, they do 360s, they do 720s. They don't do pi over 3s, right? They don't do 2 pi's. So we're more comfortable with the concept of degrees. The only way you're going to get comfortable with the concept of radian is to force yourself to work with the radian. If you're always converting back to degrees, you're never allowing yourself time to get comfortable with the radian. Okay, so force yourself to work with the radian. It will help you to raise your comfort level with the radians. All right, so we are at pi over 3, and what's the coordinate? And again, I want you to be thinking longs and shorts here. So without looking, what's my coordinate? 1/2 root 3 over 2. So what's the sine value? Yeah, so remember, what is sine related to? The y value. And on the unit circle, it's not just related, it is the y value. So you got root 3 over 2. Okay. Okay, number 13, if you have the printed notes, it looks funky on here probably because yours was shifted, or does it look normal? Is mine the only one that's shifted? Oh, good, I'm glad, okay. So where's the pi over 4 spot? Where is it? Okay, so smack dab in the middle of quadrant 1. And so these are all boring. They're all in the first quadrant. I'm already getting bored. What's the coordinate? Root 2 over 2. Root 2 over 2. Okay, what's the tangent? Now I want you need to be thinking through, okay, it's going to be, according to SOHCAHTOA, it is, What's the tangent? It's 1. Yeah, it is. It's opposite over adjacent, or the y value over the x value. Okay. Any questions? All right, let's go to number 14. So write the following in terms of its cofunction. Okay, so this is the 3 rules I gave you just a few minutes ago. Okay, so for number 14, whose cofunction is secant? Now listen to the question, because I did not ask whose partner in crime is secant. So this is a different question. Whose cofunction is secant? Cosecant. Okay, so they're cofunctions of each other. And what does the rule say about cofunctions of each other? Their complements are equal to each other. Okay, so if I'm given secant of 39, you said that the cofunction is what? Cosecant. And what am I looking for a number? Say it again. The complement. What's the complement? Isn't it 51? You can use your calculator on adding and subtracting if you want to. 51. Okay. You do this one. And once you feel like you have it, show somebody close by. If your answers are different from each other's, then ask some people that widen your circle a little bit, widen your group. Have you asked anybody yet? Yeah, talk to each other. Are we all in agreement? What does that mean? It's either a yes or it's a no. You guys in agreement? Do you have the same answer? If you don't have the same answer, then you're not in agreement. If you do have the same answer, you are in agreement. It's like, here, are you cold? All right, who is the co-function? Cosine. All right, so that's the first thing that you should be agreeing on with each other. How am I going to find my angle? What math do I do to find my angle? What math am I doing? Somebody? I just can't understand you. I hear you talking, but I can't understand you. Can you hear what she's saying? Okay, so it's not just me. You mean with the 38 degrees and 29 minutes? Is that what you mean? Or is that what she said? Oh, thank you for the interpretation, because I had no idea what she was saying. So she said DMS to degrees? Okay, so I don't have to do that. I don't have to. You can, but you don't have to. What kind of math do you need to do to find my angle? Subtract from what? Why are you subtracting from 90? Oh, because they're complements. Okay, so really all I need to do either mentally or in my calculator is 90 minus 38 degrees 29 minutes. Okay, and again, you can either do that in your calculator or you can do that mentally, either one. Now, if your original question is in degrees and minutes, your answer needs to be in degrees and minutes. Okay, you need to basically parrot what they gave you. So what is my angle then? 51 degrees, 31 minutes. 51 degrees, 31 minutes. Okay, so if you're working in your calculator, the easiest way to do this is 90 minus 38 degrees, 29 minutes. Go back to the angle menu and do number 4 DMS. Okay, and you can do it all in one line. You don't have to do it separately. Okay, all right. So now let's take a look. Where's pi over 3? No, that's not what I'm asking. Sorry. Do this one. I already forgot what my directions were. Okay, remember what you're looking for. You're not looking for the sine of pi over 3. The sine of pi over 3 is root 3 over 2. That's not the right answer here. Okay, so follow the directions. This one you're not going to need a calculator on if you're willing to look at the unit circle. Unit circle is the easier method, honestly. So what's the cofunction for sine? Cosine. And what's the complement for pi over 3? Pi over 6. And if you're going, okay, how do you get that again? We talked about this last time. Are you looking at your unit circle? Where is pi over 3? It's the second spoke in the first quadrant. How many more slices of pie do you have to get through? How many more, how many more slices do you have to get through to get up to the top? One more slice. And what's one slice worth? Pi over 6. Pi over 6. Okay. So now you could have done pi over 2. You could have done the math. Pi over 2 minus pi over 3. Get a common denominator. Okay. You could have done that math. But it's much easier to just look at the unit circle and see how many more slices you have to go through. Okay. All right. Reference angle. Did I define what a reference angle is at some point? I did. Okay, good. All right, so the reference angle, what did that definition say? Because I saw it and then I totally ignored it. What does that definition say? What's a reference angle?
How far away from the x-axis?
Good. How far away from the x-axis are you? How far away from the x-axis are you? Okay, so this is easiest to think about if you visualize what I'm talking about. So the x-axis is the horizontal axis, okay? And I've got a positive x-axis and I have a negative x-axis, all right? What I really want to know is if I'm in the first quadrant, how far away am I from the x-axis? If I'm in the second quadrant, how far away am I from the x-axis? If I'm down in the third quadrant, how far am I away from the x-axis? And if I'm down in the fourth quadrant, how far am I away from the x-axis? Okay, this is always going to be a positive number because think about it. If I said, how far is Walmart from here? You're never going to tell me a negative distance, right? Even if you walk or drive backwards, we just don't do that. Distance is positive. So it's always going to be a positive number. And it's always going to be rather small, you know, like between 0 and 90. Or between 0 and pi over 2. Okay, because you're never more than a quadrant away from the x-axis. Okay, so first of all, what you want to do for these is think about where is the angle in question. Where is the angle? So where's 212 degrees? Quadrant, say it again. Somewhere in quadrant 3, right? How far away is the x-axis? Well, what angle is at the x-axis? 180 is the closest x-axis angle. So how far away is this? Say it again. 32 degrees. And I really did this poorly because 212 degrees is not equal to 32 degrees. So can you just put an arrow on here so that, you know, it's not equal. It's just this is the reference angle or something. But they're not equal. I mean, if you have $212 in your pocket, it's not the same thing as having $32 in your pocket. They're not the same. So that's my fault. All right, number 18. Where is negative 60 degrees? Which quadrant? Fourth quadrant, like right here, right? Now, find out where the closest x-axis is. Okay, I'm pretty sure you can see it visually. What is my reference angle for negative 60 degrees? This one's slightly tricky. So can you at least tell me where the closest x-axis is? I mean, you've either got the positive x-axis or you've got the negative x-axis. Which is the closest one? This one over here, right? Okay, So we're working in degrees right now. What's the only thing this guy is in degrees? 0 degrees or 360 degrees. Okay, so then the question is my closest x-axis answer, is my reference angle going to be at 0 degrees, or is my reference angle going to be at 360 degrees? Oh, this is weird. Okay, so let me go ask it this way. I think this will make more sense to you. How far away from the x-axis is that angle? 60 degrees. There you have it. It's 60 degrees away. Okay. Example number 19. I think this one's in radians. Where is 7 pi over 6? Third quadrant? Where in the third quadrant? It's the first spoke into the third quadrant, isn't it? Okay. How far away from the x-axis is that? Pi over 6. Pi over 6. Isn't it one slice away? One spoke away? And we already know that one spoke is pi over 6. All right. I'm gonna do it on time. Okay, so what I want you to do next, you guys are gonna do this one, but I'm gonna walk you through it, okay? So I want you beside this question, beside number 20, I want you to just draw a little miniature circle, and I want you to mark the position for 315 degrees. Draw a small circle. Mark the position for 315 degrees. If you can't remember where that is, look it up. Now give it a coordinate. Write down the coordinate next to that position. Now, this is exactly like the questions that we did a couple of minutes ago. Let me take you back to 8, 9, 10, and 11. Remember how I was saying these are boring, these are all in the first quadrant. Okay, so now we're stepping outside the first quadrant, all right? But it's the same concept. So you're going to use the exact same idea that we did from 8 through 11. Only now, I'm not just asking you for one trig function. Now I'm asking you for all 6 trig functions. Okay? So you've got your position marked. You've got your coordinate marked. Now go give me all 6 trig functions at 315 degrees. Okay, check your work on the screen. The same thing I do. Okay. All right. For the next one, draw yourself a circle. Mark the position of 5 pi over 3. Try to get the coordinate without looking. Thinking of longs and shorts, try to get the coordinate without looking. Mark the position. Now, before you move on, go ahead and double check and make sure you got your position and the coordinate correct. And then proceed and get the 6 trig values. All right, so you should have had a 4th quadrant position. And it's the position, it's the spoke that's closer to the bottom, closer to the y-axis. And you can see, I don't know if you can see this on your own little sketch, but on my sketch, I've made it pretty obvious where my x piece is my short piece, my y piece is my long piece. If you exaggerate your picture a little bit, you'll always be able to see your longs and your shorts. So then my x piece is short, that's a half. My y piece is long, that's negative root 3 over 2. Negative because it's going down. Okay, so then my sine value is the y value, negative root 3 over 2. Cosine value, x value, it's a half. Do you remember how I told you a few minutes ago that the more you work with tangent, the more you're going to accidentally memorize, okay? So the tangent at 5 pi over 3, again, a couple ways that you can think about it. You can think about this as opposite over adjacent. You can think about this as y value over x value. You ready for this? I'm going to give you a new one. Tangent is not just y value over x value. You could also say that tangent is sine over cosine. Tangent is sine over cosine. So if your sines and your cosines are correct, I don't even need to think about opposite over adjacent. I don't need to think about y value over x value. I can just say, oh, I already have my sine and my cosine. Let's just do one over the other. Okay, so this is going to be negative root 3 over 2 over 1/2. And that's going to end up being a negative root 3 once I cancel out my 2's. All right, flip all those other guys over. At 5 pi over 3, this is going to be negative 2 over root 3, but that's going to end up being negative 2 root 3 over 3 once I rationalize the denominator. Secant's the easy one. And then cotangent, hey guys, if tangent is sine over cosine, what's cotangent? cosine over sine. It's the reciprocal, right? So tangent is sine over cosine. So cotangent is cosine over sine. Okay? Or you can just say take root 3 and flip it over, and you're going to end up with negative root 3 over 3. You see, you didn't show your work on that one. I know, I've already done that work today. Any questions? Okay. Here's another one. So take the same route, take the same method. Come up with your position, your coordinate, and then find your 6 trig values. So again, maybe try to find the position without looking. Try to find the coordinate without looking. But check your work before you move on. Make sure you get the right spot. If I haven't made it around to you, go ahead and check with somebody close by.
Does that change your formula? Yeah. And it's going to change the order too, right? This is negative 7%. So where is negative 7%? Okay, so let's think about how you got here. To get here, you have to go through one quadrant, two quadrants, and one more spoke. What makes an angle negative? Okay, so let's see if we can go the exact same amount along this whole, just in the opposite direction. So if that's the case, where would you land?
In this quadrant?
Mm-hmm. Okay.
All right, I think I made it around to pretty much everybody. This one was a little tricky. So all of you who struggled, which was the majority, you marked 7 pi over 6 correctly, but you didn't mark negative 7 pi over 6 correctly. So, so this is, I'm going to go through it again, even though everybody in here, I pretty much hit everybody, or you got it right in the first place. We know that positive 7 pi over 6 is right here. And the way we get there is that we go through one whole quadrant, and then one more spoke, right? But we don't want positive 7 pi over 6. We want negative 7 pi over 6, which means we go the same distance. We just go the opposite direction. So that means that I'm going to go through one whole quadrant, and then one more spoke, landing you at the position 5 pi over 6. Okay? Because 5 pi over 6 is going to be coterminal, there's a great word for us, coterminal to negative 7 pi over 6. All right? Coordinate here is going to be, you see I've got a long first, so that's going to be a negative root 3 over 2. And then I have a short y value, so that's going to be a positive 1/2. All right? So what, if you had left it at the 7 pi over 6 position, some of your answers would have been correct, but not all of them. You would have the right numbers. It would have been the positives and the negs that would have been messed up. Okay, so let's go ahead then and jump right on in. My sine value is going to be my y value, so that's a 1/2. Cosecant then is the flip of that. Cosine is going to be my x value, so that's negative root 3 over 2. The flip of that one is going to be negative 2 root 3 over 3. We just did that work a few minutes ago. Tangent, sine over cosine, y value over x value, opposite over adjacent. So that's going to be a 1/2 over a root 3 over 2. That's going to end up being a negative root 3 over 3. Okay, the flip of that is just a negative root 3. Okay, so if you had left it in the wrong spot, you would have gotten a couple of things right, but not everything. Okay, any questions on that? Okay, so what are we going to do now? Are you thinking too hard? You're going to pull out your calculator. Okay, so number 23 is going to be really hard. You ready? Push the sign button. Push the 3. Push the 8. Push enter. Oh, my batteries are low. You should have gotten 0.6157. Now, if you didn't, do me a favor. Find your mode button. Push your mode button. What do you see on that screen that might be helpful? Yeah, are you in radians? And what should you be in for number 23? We should be in degrees. Okay, so switch it over to degrees. Then go back to your home screen. You can just do second enter when you get back to your home screen. It'll retype it in for you. And this time you should get this. Okay, did it work that time? Why did I round like this? Robert's rounding rules. Okay. Do 25. Don't do 24. Do 25. Show somebody close by your calculator screen. Just hold it up so they can see it. What'd you get? Yes. Okay. So those two, easy peasy, right? No big deal. As long as you have a calculator, it's no big deal. If you don't have a calculator, that could be a problem. Okay. 24. All right, so when you look at your calculator, what's the dilemma? There is no cosecant button. And don't you start thinking that sine with the -1 is the same thing as cosecant, because it isn't. Okay? That does not say sine to the negative first power. We know that negative first powers flip things over for us, but that's not what this is. That's actually the sine inverse button, and we're going to use that button, just not for this question. Okay? So what do we do then? I mean, what is cosecant? 1 over sine. Okay, well, if I know my angle then, all I need to do is treat this as 1 divided by cosecant of 145 degrees, 45 minutes. Because 1 over sine, 1 over sine is the same thing as cosecant. All right, did you get 1.7768? Okay. 26 is another easy one. Go ahead and do that one. Show it to somebody close by. Just show your screen. So you should have gotten negative 3.3805. Oh, what's wrong? I get that. So then, I promise you I'm right. I do make mistakes in front of you, but not this time. So if this is not what you have, what's the problem? To what? Why? Oh, there's no degree symbol. And you remember that the lack of a degree symbol automatically means radians. Now, I could have been really nice to you, and I could have told you that before we went into that, right? But it's going to stick a little bit better if you make a mistake. Guys, mistakes is where the learning takes place. If I didn't let you make a mistake, you wouldn't learn it. Okay? So please, on this next test, the one that's a week from today, you will go back and forth and back and forth and back and forth between degrees and radians on your calculator probably 4 to 6 times. And when you figure there might only be 20 or 24 questions on the test, that's a significant amount. But there's nobody that's going to stand over your shoulder going, did you check your mode? Okay, nobody's going to do that to you. And if it said it in my lab, I edited the question to take it out because I want you to remember it. I don't want my lab to remember it for you. I want you to remember it. Okay, so you will be switching back and forth between degree mode and radian mode multiple times on the test. All right, number 27. Okay, so this question, this next set of questions, no calculators on this. Okay. I have already written the test, and let me tell you, you've got multiples of these on the test. Okay. So you do want your unit circle. Let me say this because I'm thinking of it right this minute, and if I wait, I'll forget. As far as your test is concerned, I will provide a blank unit circle for you to do with whatever you want. Fill it out if it will help you. Use it for scrap paper if it won't help you. I don't care. There won't be any points assigned to it. Okay? So I will provide a blank unit circle to do with what you want. All right? Okay, so we're looking at the unit circle. First of all, let's pay attention to the directions. We are looking for what? What does it say? First of all, it says all values. Okay. This means that there might be more than one. So I'm looking for all values of what? Beta. And beta is just a fancy name for a what? For an angle. Okay. So I'm looking for angles. My answer is going to be in angles somehow. Am I going to be working in, I'm not using the calculator, but is your brain going to be in degree mode or radian mode? Look at the directions. The degree mode, how do you know your brain's going to be in degree mode? Because it says from 0 degrees to 360 degrees. Okay? So the interval tells you that you're working in degrees right now. Okay? Okay, so what you're going to do is I want you to go to your unit circle. The cosine value is related to what? The x's. So I want you to look at your circle. We're going to come up with a plan first. Look at your circle. Where do I have x values that are equal to negative root 3 over 2? Or maybe you could ask yourself this question the same way or a different way. Where do you have long x values that are negative? Long x values that are negative. At what angles do you have x values that are negative root 3 over 2? How about, give me an answer, somebody. Where? 150 degrees. Okay. Anywhere else? 210. Anywhere else? Well, I mean, where is cosine negative? In which quadrants is cosine negative? 2 and 3, right? Because it's an x value, so it can only be on the left side of the circle. Okay, so then there aren't any other places on the left side of the circle that have that long x value. There just aren't any other places. Okay, so then my theta value is going to be at 150 degrees and 210 degrees. That's all the places from 0 to 360. All right, let's jump down to 29, the one right underneath. Okay, now for this one, let's come up with a plan. Again, always come up with a plan first. See, the bad thing about this one is that when you go to your unit circle, you don't have tangent values marked on your unit circle. All right, so that's the bad part about this one. In fact, you only have sines and cosines. Any of the other 4 you don't have marked. But we have talked about how to know where tangent is negative. So where is tangent negative? Quadrant 2 and quadrant, what was the other one? 4. Quadrant 2 and quadrant 4. Remember, all students take calculus? Okay. Everything's positive in quadrant 1. Tangent is positive in quadrant 3. Okay, so 2 and 4 were, so this is my plan. I know I'm going to have an answer in quadrant 2. I know I'm going to have an answer in quadrant 4. Okay, so then the next thing I have to think about is where will tangent equal that number root 3 over 3? Now, you weren't allowed to use a calculator, which means you have to use the unit circle. Okay, if you think through the logic, okay, so stick with me on this. If you have to use the unit circle, can it be at the 45 spot in the middle of quadrant 2? What's the tangent at the smack dab in the middle spot in quadrant 2? Well, -1, right? Because the x value is exactly the same as the y value. So it can't be at the 45 spots in quadrant 2. That's impossible. Well, aren't there only 2 more spots left? So it has to either be at the 120 spot or it has to be at the 150 spot. Would you agree? Because those are the only 2 spots left in quadrant 2. Okay, I'll deal with quadrant 4 in a minute. But those are the only 2 spots left in quadrant 2. So you remember me telling you a few minutes ago that the more we do certain maths, you're going to accidentally memorize it? Okay, so let's think through. Let's do a little bit of trial and error, and it's okay to error. Okay, it's all right to do that. So if it can only be at the 120 spot or the 150 spot, what's the coordinate at the 120 spot? Think longs and shorts. What's the coordinate at the 120 spot? -1/2 root 3 over 2. Now remember, I'm working with tangents. So tangent is, we've got a lot of options now. You could say it's the opposite over the adjacent. You could say it's the y value over the x value. You could say it's the sine value over the cosine value. A lot of options. Probably the easiest of those would be the y value over the x value. So the question is, will root 3 over 2 over 1/2, my y value over my x value, will that give me root 3 over 3? It won't, will it? Throw it out. I don't want that one. So I'm guessing it's going to be the 150, but can we just double check and make sure? Okay. What is the longs and shorts? What's the coordinate for the 150 spot? Yeah. 1/2. Okay, so then this time tangent is going to be the y value over the x value. 1/2 over root 3 over 2. Will that give me root 3 over 3? Yeah, it will. Okay, so I know then that my first answer, theta, has to be 150 degrees. Okay, now we need to go through the same process for quadrant 4. The good news is the work is really already done. So I don't have to go through all of the work. I know it's not at the 45 position. It's not smack dab in the middle. I just need the position that has the root 3 over 2, the long piece as the x piece and the short piece as the y piece. So where is that going to be then? Can you say it louder? 330. By the way, I'll throw out a nice little hint for you. Do you notice that these two are directly across the circle from each other? Tangent and cotangent values, that ends up happening all the time. Only for the tangents and the cotangents. It doesn't work for sines and cosines. But tangents and cotangents that are directly opposite each other from the circle, tangent values opposite each other, cotangent values opposite each other, they end up being the same thing. Okay? Because it ends up being a y over x or an x over y that's identical. It's just we're moving the negatives around. Okay? But we end up with the exact same values. So so that's a nice little tidbit there. I have 4 minutes. Okay, so let's talk through, I'm not going to have a chance to do these questions, but let's talk through how are the directions for the next 2 questions? How are they different from the last set that I just did? Yeah, it doesn't say no calculators. Now look at those numbers. Thank heavens, right? Okay, but I still have to find all the places where it's true. I still have to come up with a good plan. So that's what I'll do, and then I'll let you go. Let's come up with a good plan for number 30. Think through, all students take calculus. Where is cosine positive? Where is cosine positive? First quadrant and fourth quadrant. First quadrant and fourth quadrant. All students take calculus. Okay? Remember, it's the x value. Cosine's related to the x value. So x's are positive in quadrants 1 and 4. So I don't know what my answer is going to be, but I do know that I'm going to have an answer in the first quadrant and I'm going to have an answer in the fourth quadrant when I'm all done with this. I have to have 2 answers. Okay, so I know that I'll get one in the first quadrant and one in the fourth quadrant. How about for 31? Again, only coming up with a plan. This is where I'll pick up next time. What's my plan for this question? So where does that happen? Quadrant 1 and quadrant 2. Remember, your sign is your y value. We're looking for positive y values here. Okay, so when I'm all finished, I'll have an answer in first quadrant, answer in second quadrant. Okay, your calculator though is only going to give you one of those. You've got to go find the other one. but that's where we'll pick up next time. So I don't have I don't have a ton left to do, and I would rather do those 4 when your brain is fresh anyway. If I try to give it to you right now, you're not going to remember it. Okay, so we'll do those 4, then we'll do section 5, and then we'll have lab time next time, okay?